Hi and welcome to the first lesson of the course. In this section, we are going to be spending time understanding the SAS syntax. SAS has two steps. It's a data step and a procedure step. Every step in SAS, it begins with the data statement or a PROC statement. We can use data step to compute the values for new variables, or we can say we create new data sets from existing data sets. We are going to also be seeing how we can use data step in order to check and correct errors in our data sets. So that is an example of how we can create a new data set using data step in SAS. We will be learning all of these in the following sections. Now, let us understand a procedure or PROC step in SAS. So, a procedure step, we use a keyword PROC. So it's simply just a group of procedure statements. Each and every procedure statement in SAS, it begins with a statement whose name begins with the word PROC. So everything that is going to follow after PROC is simply just will be keywords that will describe the purpose of the procedure. Say for example, we are sorting data in SAS. To sort data in SAS, we'll be using a procedure sort. And to print out our dataset, how our dataset looks like, we're going to be using a procedure for printing, which is PROC print. We can use procedure statements in SAS to analyze data, summary statistics, tables, report, and chart, where we visualize our dataset, create SQL queries, and also perform other analysis and operations in our dataset. So that just provides an example of how this is written in SAS. Hi everyone, welcome to this section of the course. In this section, we are going to learn how we can define variables in SAS by looking into different ways to define or create variables in SAS. So variables are treated as a store of value. So in this section, we're going to be looking into how we can create variables using assignment statements and using an input statement. And lastly, we're going to see how can we create datasets using numbered range list. And lastly, we are going to see how can we view the attributes in our dataset, such as looking into the types of variables in the dataset by using a procedure content. You can create a variable in SAS by an assignment statement and a data step. To do so, let's create a new variable using a data step. Let's say we have a data patient. So the name of our data is patient, and in a semicolon. So this data set contains the age and the name of our patient. So we can use a data step, right? And to create a variable, our first variable is going to be age, which is age, and we assign, let's say, the value 21. And we end in a semicolon. The other variable is going to be the name of the patient. Say the name of this patient is John, and end in a semicolon. As discussed previously, the data step ends in a run statement. Okay, so let us see what this code means. So at first, we created a numeric variable, which is age, and the name of our patient, and the name of our patient, which is John. Since the name is a character variable, we enclosed it in quotation marks. The next way we can create a variable in SAS is by using an input statement. So now we are defining a variable using an input statement. We first create a size data set as in the previous video, which is data patient. Then we use an input statement. So the input statement in SAS is a keyword. So to create variables using an input statement, we first list our variables, which is age, then name. Now, since name is a character variable, in SAS, when using an input statement, to specify that a certain variable is a character variable, we use a $sign. So this will simply mean that variable name is a character variable. So we indicate it by $sign, then semicolon. Following is a data line statement. So following is data line statement. So this data line statement is used to read the data directly into the program rather than the data that is stored in an external file like a CSV or an Excel file. We can only use one data line statement in each data step. To enter multiple sets of data line statements, we have to create a new or a separate data step. Okay, in the place of we can also use cut statement. Okay, now we are ready to enter the values in our data set. So to enter the values, so we refer to this data as raw data. So we are reading the data directly in the program. So we enter the values based on location. So what does it mean? So we saw that the age is going to be 21. So this is how we enter the data. This 21 means that we are assigning the variable age to 21. And the name of our patient is John. There is no need to enter the quotation marks when we are using an input statement. And the way we end is that we put a semicolon into the next line and run. So this is how you can create a variable using an input statement and also data lines. Another way we can create a variable in SAS is if we are using a variable numbered range list. Say, for example, you want to create variables, say, from day 1 to day 7. To not continuously define day 1, day 2, day 3, up to day 7, you can just create a variable numbered range list. Say we have our data that will record temperatures from day 1 to day 7. So let's define our data to be temperature. Right. So we create a variable numbered range list also using an input statement. So this states that we want to read from day 1 to day 7. So to do so, we can have day 1 to day 7. So this is how we can create a variable numbered range list. And following that is a semicolon. Then hit data lines. Following, we are ready to input our data. Say 74, 75, 82, 84, 85, 86, and 89. And we put the semicolon in the next line. Then you're done. So let us print this data and see how it looks like. Run that. So it has created the variables from day 1, day 2, day 3, day 4, all up to day 7 without having to specify day 1, day 2, day 3, day 4, and so on. So this is how you can create a variable numbered range list in SAS. Now let's say we want to view variable attributes like the name of the variables in our data and also the variable types. SAS provides a procedure called contents. So PROC contents can be used to view variable types and names, and also the number of observations in the data set, as well as the number of variables. Say, for example, we use this procedure in our simple data set that we created, which is patients. So we're going to use PROC contents. We have an option to specify the name of the data we want to use, which is patient. And we run it. So one of the things in this course that you're going to do is we are going to be interpreting also the results that we are going to be seeing from SAS Studio. So let us look at what we are seeing from the output. What we can observe from the output is that the dataset had a variable name called age, which is of type numeric. It has length 8. And also we have variable which is name of type character variable. There is also some additional output like how many variables, which is 2, observation, which is 1, because there is only one patient. Hi, welcome to this section of the course. In this section of the course, we are going to be learning how can we use SAS operators. But first, let us understand what is a SAS operator. A SAS operator is simply just a symbol that we use to perform calculations or do comparisons or some logical operations. Arithmetic operators are simply just used to perform math calculations. Say, for example, we have 2 asterisks. So 2 asterisks are simply just for representing the exponents. And we also have a 1 asterisk for multiplication, and then that is a symbol for division, addition, and subtraction. Let us head over to SAS Studio to see how we can simply do a few arithmetic calculations using these arithmetic operators. Now, let us see how can we do arithmetic calculations in SAS. Say we have our data set, which is going to be arithmetic. Now, let's say we have 2 variables, A being 8 and B being 4. So the first thing that we are going to do, we are going to be defining new variables from existing variables. So to do that, we can have variable C. Say we want to have A divided by B. And we have D, which is going to be which is going to be A plus B. And we can have subtraction, which is A subtract B, and we can also have, I'm just going to keep on continuing with A, B, C, D, E, and F. So we are going to have, say we want to have 4. Say we want to have B raised to the power of 2, and we can. So this is how you can specify arithmetic operations in SAS. So let's run that and observe the output data. So this is all the variables that we have defined from A up to F. Now, we are simply just going to be looking into comparison operators. However, most of these operators work with if statements. So in this section, we're simply just going to be explaining and looking into them and understanding them, how they are used in SAS. So comparison operators simply just express a condition. So if the comparison is true, we have results of 1. However, if the comparison is false, the result is 0. Most of these operators, as I did mention, they are being used with if statements. So this is simply just a list of all the comparison operators that are being used in SAS. First, we have equals to, not equals to, greater than, less than, greater than or equals to, less than or equals to, equal to 1, of a list. So an in operator might be new, but an in operator simply just check if on a list is a particular variable included in that list. So most of these operators are used with if statements or where statements that we will cover later in the course. Another operators are logical operators, or sometimes we call them Boolean operators. Boolean operators are usually used in expression. We want to link a sequence of expressions into a compound expression. So if you're looking into AND, so for example, if both of the quantities linked by an AND are true, then the result of the AND operator is 1. So we will look into this. Both conditions have to be true. But if we are using OR logical operator, either of the conditions have to be true. So we also have additional logical operators. But all of these operators, we are going to look them when we are covering if statements. Welcome to this section of the course. In this section, we are going to learn how can we access data in SAS by making use of SAS libraries, and also learn how can we import using an import procedure in SAS. We're also going to learn how can we use an input statement to read the data sets that are already defined within SAS programs. So, a SAS library. A library is simply just a collection of one or more SAS files, including SAS datasets that are referenced and stored as a unit. So we might have multiple SAS files that are stored in one unit. So those SAS files will be stored inside a library. So that is the syntax of how can we define a library in SAS. A library starts with a keyword which is libname. Then following is a libref. So this is a reference to the library. So the reference to the library, we can use it to reference the location of our data sets. Say for example, we have mylib.myfile. So that reference to the library, which is mylib, we can use it to access a library member, which is myfile. Following is an engine. SAS provides several engines that we can use to access files or files formatted by another applications or DBMS. For example, if we were to use a library to read an Excel spreadsheet, we will use an engine Excel SX. And then following is the location. So we also have to specify the path where our data is located. To be able to access that Excel file and CSV file on SAS On Demands for academics using SAS Studio, one need to first upload this data into the server. So if you go to your left and you click, and you can just see that there is certain folder shortcuts and files. So if you click on that, we will create this file. We will create files under these files folder. So to do that is we are going to right click and say and go to new folder. So let's call this folder SAS. So we have created this new folder. Now we need to upload those two files into SAS Studio. To do that, you click on this new folder and you go to upload and click on choose file. Then go to wherever you downloaded those files. In this case, it's in downloads. Going to start with this one and upload. It's now should be showing under access data folder. I'm going to upload the second file, class birth date, and click on upload. So now we have uploaded these two files in SAS Studio. The first thing we are going to be learning about is how can we access these Excel files and CSV files. But first, let us look at how can we access an Excel file through a library. First, as we learned the syntax in the previous video, we are going to first start with an option, valid name, and set it to be equals to V7. So this option makes sure that the naming of tables follows SAS naming convention. Next is we need lib name keyword. Okay, what follows is the reference. So we are going to save this as say XL plus to create the name of our reference. What follows is the engine. So for Excel files, the engine is XLSX. Now, we want to get the location. So in this case, to get the location, since this is the file that you require and we want to use, you right click and you go to properties. And then you will see the location. You copy all of that and paste. Now the location will be in quotation marks. Now we have created our first library. Let's run that. So SAS has created a library for us. If you go straight to libraries and you click on that, we should be able to see XL class, the reference to this library. If you click on that, we can be able to see all the tables that are being stored inside this library. Now we want to access those tables. First, let's say we want to see how class table looks like. So we can use PROC content and say data equals to. Now, to be able to access class table which exists inside the library that we created, we are going to use the reference, which is XL class. If we click on dot, SAS will be able to show to you what access do you have using this reference. So now let's look at class tables. And we run it. So we can now have a look at all the variables, the variable types, the length and format that exist inside class table. Now let us understand how can we use an import procedure to import a CSV file. Now the syntax is like this. We first specify the procedure, which is PROC import. Then we specify the location. Then DBMS specifies the type of the data that we are importing in SAS. And then we have out, which specify the output table. Where do we want to output this dataset that we have imported in SAS? Then we also have a last option, which is replace. Replace will simply just make sure that if the output table already exists, we want to replace it with this new one. If we are going to use an import procedure to import an Excel file, we will follow the same syntax as in the CSV file. The difference is that we now have to specify sheet. So let's say we have an Excel spreadsheet. So this Excel spreadsheet consists of several number of sheets. We will use sheet to specify a sheet name that you want to import in SAS. Now we are going to see how can we use an import procedure to read an unstructured dataset in a CSV file. So to do that, we have procedure, which is import, and we have to specify the location. So the location is properties, copy all of that. Right. So the next thing is we have to specify the type of the file that is being imported, since this is an unstructured data set. To do that, we use DBMS, which stands for Database Management System. So this specifies the type of data to import. In this case, we are importing a CSV file, but there are also other options. SAS provides them here. So it's going to be CSV. The next thing is we have to specify where are we going to store this data. So to do that, we use an option which is out. So let us name our data set. Let's just call it build date. And we can also add a replace option. So this option will overwrite an existing SAS data set. If it already exists, it will replace it and replace and close it. And click on run. Now, to be able to view this newly created data set, we have to use that name, which is birth date and run. So this is how this data set looks like in SAS. Next, we are going to import Excel. Now, to import an Excel file, we have to have an addition option or an addition statement, which is sheet statement. Say, for example, we look into this data set that we have. It has multiple sheets. So if we want to access using PROC import, we are not going to specify a library here. We are going to specify the sheet name. So to do that, PROC import data file. Now go here and copy this. Right, DBMS, we're importing an Excel file. Excel SS. Right. So now we want to output it into the class name that we call Excel plus replace run. Okay. See. Let's try to run this. We didn't specify a sheet name. So as you can observe here is that we simply just have that data set, which is class. Now we're going to see how we can specify the sheet name. To do that is we come here and we have an option which is sheet. So let's say we want to access this table here, which is the teachers, class teachers. So the name of the sheet is class teachers. Okay. Now let's rename it and say Excel class. Say Excel teachers and let's try to run this. So we have now accessed a sheet which is class teachers. So we outputted it. So this is how you can access an unstructured data to CSV file using an import statement. And this is how you can access Excel file using an import statement to specify a sheet name. In this video, we are going to learn how can we read raw instrument data in SAS. At the beginning of this course, we were creating variables using an input statement and data line statement. Well, that is how we can have a data that exists within a SAS program itself. We didn't import it from a CSV file or an Excel file or anywhere else. We just defined this data and it existed within SAS. So to define such data, we use an input statement, and they start with to input the values in the data set. Start with data line statements, and they end in a semicolon on a new line. Say, for example, we have this data of patients. So it followed with an input statement. So now an input statement takes the variables, the variable names. However, these variable names are the column names in a SAS table. So let's say we have an A, we have the age, name, and the weight of the patient. I made a mistake. When I was defining the variable or the column name, I left a dollar sign. Since a column name is a character variable, I need a dollar sign. So now we are ready to input raw data, which starts with data lines statements. And let's say this one is 21 and his name is Helen, and Helen has a weight of 13.2. Let's say this one is, I'm just making up names. This one is 50. His name is Henry. 15. And semicolon and run. Now let's have a look at how our data looks like. So this is how our data looks like. Welcome to this section part of the course. In this section, we are going to be looking into how we can control which variables we see in the output during data step. SAS provides us with statements such as drop, keep, or rename. So as the name says, for rename statements, we want to change the name of the variables before we process that variable. And as for drop or keep keeps includes or exclude variables from processing. Let us head over to SAS Studio to understand these statements better. SAS provide statements which control which variables can we see in the output data set. Those statements are keep, drop, rename, and many others. But in this course, we're just going to show how to use keep, drop, and rename statements. So let's start. So here we are doing control output. So let's define this new data set. Let's call it class 1. And we want to use its new class. First, let us see how does it look like. Run it. So These are the variables that are in our data set. So now let's say we want to change the variable name, say sex, to become gender. So to do that, we come here after set statement, we use rename. So which variable we want to rename is sex. We want to call it gender. Now, one mistake that one might do here is to put gender in quotation marks. This in SAS works in this way. So you have to simply just say the old variable and you want the name of the new variable. So let's run this. And from the output, we can observe that sex has been renamed to gender. So now let's say you say, now we only just want to keep the name, gender, and age of the students in the class. So to do that, we can use keep statement. Keep statement works in this way. We specify those variables that we want to keep when we are outputting SAS data. So let's look at our results. We said we only want to keep name, gender, and age. So we specify those variables that we want to keep, which is name, gender, and age. Let's run that. Now, SAS will give us a warning. It says the variable gender in drop, keep, or rename list has never been referenced. The variable sex in drop, keep, or rename list has never been referenced. So how can we do that? Best way that we can do is if we first run a keep statement, then we run a rename statement. So this is how we can do this. First, we run a keep statement. Then after a keep statement, we run a rename statement. Let's run it. So we made a mistake. Should have been 6. Then let's run it. So this is how we can use the keep statement. So now let's say we want to drop certain variables. So looking into this data, we can see that we had additional variables, which is height and weight. So if we had used drop statement, we will say drop height and weight. So let's first run this. So this is our data set. So let's see how we can use drop to get the same output. So we can use drop, the name of our variables, height, weight. Run it. So we get the same output. We have dropped height and weight from the output. And we have kept name, sex, and age. So this is how we can control the variables that appear on the output. SAS also provide an additional way where we can select those type of rows that meet a particular condition. So let's first look into our data. So let's say in our data, we only want to keep the information about female students. So we can use a where statement in that case. So we say where sex equals to F. Now, this says that only keep the observations where sex is equals to female. Let's run that. And this is the output. In addition, we can simply just decide, okay, now we only want information about female students, but with the age that is less than 15. So to do that, we can use and say we only want where the age is less than 15 and run that. And this is the output. Welcome to this part of the course. In this section, we are going to be looking into how we can use if, then, or else statements in SAS. The way if statements work is that they execute SAS statement or SAS code only if a particular condition is satisfied. Say, for example, looking into this example that we have, in our data step, we can see that if age is greater than 14 and weight is less than 115, we want to output that observation in the data which we call if example. So based on those conditions, we want to execute the following statements. Then if, then, or else statements. If, then, or else statements execute a size statement for rows that also meet specific conditions. So let's look, for example, let's say if age is greater than 14 and weight is less than 115. So if that condition is not met, SAS will execute whatever that you specified on the else statements. Let us head over to SAS Studio so that this makes much sense. In this video, we are going to learn how can we use if, then, or else statements in SAS. These statements, they only execute a SAS statement if a particular condition is being met. Let us look at how our data looks like. If you run this, so our data only contains two columns, the name of the student and also the test scores. What we are going to do is we are going to have grade levels, but these grade levels are based on the test scores of each student. So let us see how can one do this in SAS. So first we create our data set. Let's call it grade levels. We want to use marks. Following is our if statements. So if statement in SAS has a following syntax. We have if, then the condition. So what is our condition? Our condition is that if we have a test score that has a value that is greater or equals to 80. What do we want to do? Then we want to have level which is A. So based on the test score, a student will be graded or will have a level which is A. Else, if that is not the condition, we need to set another condition. So we use else if. Else if the test score is greater or equals to 70. So these are the test scores that are between 70 and 80. And test score is less than 80. So if this condition is met, so these are the test marks or the test scores that are between the value of 80 and 70%. Then the level the student will get is B. If both of these if and else if statements are not true, so we will grade the student level C. And to do that, we use an else statement. So we simply just say else level is C. Then we are done. So let's see how our new data sets look like. So from the output, we can observe that we've created a new column based on imposing a condition on test scores. Next, we are going to demonstrate the else, the if, then, or do. If, then, or do statements, they are a part of do statements. If the expression is true, then do statements will execute every statement that is between do and end. If, then, or do statements ends with an end statement. Following that, if the first condition has not been met, it will look into the next condition. Then if that condition is also not met, it will simply just execute everything that is in else. So every code that is between do and end is executed if the condition is being met. Let us head over to SAS to look at an example. If, then do statements. So these statements are part of do statements. We will go deeper with do statements when we are looking into do loops. But these statements based on condition, they execute every such step that exists between do and end. Let us demonstrate that by looking into this data, which contains the ages of students. So let's see how our data looks like. So run that. Now, we can observe from this data that we have students that have different ages. So for demonstration purposes, let's say we want to have two tables for those students that are over 15 years and for those students that are under 15. So let's do that. So this is SAS data step. We have create two tables and set statements. Which data set to use is age. Following is we want to have two groups of students, ones that are over 15 and the others that are under 15. So we say if age is greater or equals to 15, then do everything that you write here will be executed if the age of a student is greater or equals to 15 years. So let's say we only want to output that student to this table that we named over 15. And then we end. Every do statements ends with an end. So if that is not the case, we can have else do. So these are all the students that are under 15 years. So say under 15. And end. And now let's see how both these data set looks like. Oh, 15. Under 15. Run it. And this is how this data set looks like. So previously, we did the grade levels of students using if, else if, and else statements. Now, let us look into how we can do that using if, then do statements. So first, we use data. We want to have a data set that has A students, B students, and also C students. And we are going to be using marks. Okay, so I'm just going to copy this, then change a few things. So if the test score is greater or equals to 80, then do. We want to set the level of students to be A, and we want to have a separate data set that only contains A students. Not forgetting that every do is followed by end. It's the end. Else if this is the condition, then do this. Set the level, the grade level of student to be B, and output that into this table. And else do set the level of student, grade level of student, and end. And that. And let's see how all this data set looks like. A students, Let's run. And so we can observe from the output that we now have 3 data sets for A student, B student, and C student. Apologies for the noise behind. Welcome to this section part of the course. In this section, we are going to be learning about iterative do statements, the do loops. SAS have a simple iterative do statements. This statement allows us to execute a group of statements, but these statements have to be between do and end, based on a value of index variable. So a simple do loop syntax will be specifying do keyword and then an index variable, and we can have a start value to a stop value. So a start value is the initial value of our index variable, and it can be a number or an expression that evaluates to a number. Let us head over to SAS and look into a simple example. So in this video, we are going to demonstrate how can one do loops in SAS. So in SAS, the way we create loops is by specifying a do statement. And as I did mention when we were doing the if then do statement, is the fact that the do statements, all of them, they end with an end statement. So let's first learn how does loops operate in SAS. So let's call this example. So this is our first example. So let's say we have an initial value of x. However, we want to keep on adding until we reach, let's say, 3. So to do that, we want to repetitively increment x up until we reach the value of 3. So in SAS, a do statement starts with the keyword do, and then we need an index variable. So this index variable is used to tell us how many times are we looping or are we repeating whatever that we will write between do and n. So let's say we are going to start when the value of I, let's say 1, 2, 3. So this index variable starts from the value 1, 2, then 3. Let's say we want to keep on incrementing the value of x. Okay, and we end this and we run. So at first, the value of I, our index variable, will be 1. So it will be x is equal to 0 plus 1. And then for the next time, I will be 2. Then the value of x will increment by 1. So from 1 to 2, because it will say x is equal to the previous value of x, which was 1. So now it's going to be 1 plus 1. And then it moves on and say the value of I now is 3. Then it does the same thing, going to be incrementing x and say x is equal to 2 plus 1. And then we say now we stop when the value of I is equal to 2. But now let's see how will this run in SAS. So this is just a simple loop, just a simple example. right? So when this finished when I was equal to 4 and x was equal to 3. Now let us look into another example. Let's look into another example. Let's say now we start when x is just 5 and say do I, let's say, times 2, and we simply just say and after that and run. Now in this case we didn't do the looping. There is no SAS statement to execute that is between 2 and n. So our output is simply just going to be x being equals to 5 and I, which is x times 2, which is going to be 10. Let's run that. Which is what we can see from this output 8. Next, we are going to explain how to do while and do until loops. So let us understand a do while loops. A do while loop executes statements in the do loop while a condition is true. So we'll first specify the condition is the top of the loop so that the do while loop never executes if that condition is false. Another loop is a do until loop. So this loop executes in the do loop until a particular condition is true. So we evaluate the condition as the bottom of the loop so that the do until loop always executes at least once, even if the condition is false. Let us look into example to better understand these types of do loops. Now let's look at an example of a do while. So a do while loop executes. So a do while loop repetitively executes while the condition is true. Say, for example, we start with x equals to 7. So we start our loop, say, do while x, say, less than 10. And we want to keep on incrementing x. And let's say n. So what will happen in this case is that SAS will check, is 7 less than 10? And that is true, and it will increment x. Then x becomes 8. So this loop will run until x equals to 10, because 10 is not less than 10. So the do while loop executes while the condition is true. Let's run this and see the output. So it stopped when x equals to 10. When x equals to 10. Now we have another do loops, which is do until. So do until works in somehow a different way because we want to execute until a condition is true. So let's say this is a demonstration of do till. So, and let's say we start with x being 7 and it's do until we want to keep on running this loop until x is greater than 10. So This is x plus 1. And we end and run. So let me quickly explain. A do until execute statements inside a do loop until a condition is true. So is 7 greater than 10? No, that is not the truth. So it increment x. It becomes 8. Is 8 greater than 10? No. So it keeps on until x is greater than 10. So let's run this. And we have 11 because 11 is greater than 10. Let us look at a simple example of do loops. So let's say we have someone who has took out a loan of 10,000, and this person will do payments of 1,000 a month. Okay, so we just want to keep track of the balance, and also we are going to be using do loops. We will do an iterative do statement, do while, and do until. So let's first define our data. So our data is going to be a loan. So this person, so when this starts, this person will be owing 10,000. So first keep track of the balance that is remaining. It will be based on the amount that this person will pay monthly. So let's say, so first, when this person do the first payment, then the second payment, then the third payment. So if this person pays 1,000 a month, there will be a total of 10 payments. So this has to start from 1 to 10, right? And the balance, since this person is paying us 1,000 a month, that will be the number that will keep on decrementing the balance. And we want to have this in table and let's run this first. And let's run this. And this is the output that we see. We see that after doing the first payment, we'll be left with 9,000, second payment, 8,000, until we do 10 payments. So this is how we can do with the simple iterative do statement. Now, let us look at how we can do it with do while. Okay, so as stated, we want to keep on decrementing the balance. However, when the loan starts, this person will have done 0 payments. So the loan amount is 10,000. However, this person has not done any payment. So this becomes 0, right? Do while. So while this person still has a balance that is greater than 0. So while there is still amount to pay, while there is still amount to pay, we want to keep on running this loop. And then payment, and outputs in a table, and let's run. Now let us learn how can you solve the same problem but now using a do until. So first, when the loan starts, starting the same way, there is a balance of 10,000 and this person has not done any payment. So we want to keep on decrementing the balance until it is 0. So in this case, we want to keep on decrementing until the balance is 0. So it's just the same conditions. Just the same conditions and same SAS statements. So this is how you can do a do while and do until in SAS. Hi, welcome to this section part of the course. In this section, we are going to be looking into the techniques that are provided by SAS that will help us to prepare our data well for forecasting or for any machine learning algorithm. As we know that missing values and duplicated values, some of the machine learning algorithms are sensitive to that. So we are going to learn how can we deal with those in SAS. So to deal with missing observations in SAS, we are simply going to demonstrate how can we use a missing function. However, if we have duplicated values in SAS, we can use a sort. A simple syntax of a sort procedure can be seen with the keyword nodupracs. So nodupracs allows us to deal with duplicated values in a SAS dataset. And we also specify by all, which simply means it sorts by all columns to eventually show to eventually ensure that these duplicated rows are adjacent. In this video, we are going to learn how to prepare data in SAS by taking care of the missing values and identifying and removing duplicated rows. I've went ahead and already imported the dataset into SAS using a library. So let's have a look at how this data looks like. So we can see from our dataset that we have a column level which is missing some observations. So we are going to learn how to use a missing function in SAS to be able to place certain condition from other rows or from other columns using another variable in order to impute those missing values in another variable. So let's see how can we do that. First is what we know is that based on the test score, we will give a student a level of A if they have a test score that is greater than 80 or equals to 80, and for test score that is between 70 and 80, that is a B student, and the other values are simply just C student. So SAS provides a function which is missing. So let's define this new SAS table. Say new plus scores. So set plus scores. So if we are missing a level and the level and the test mark, and the test mark is above 80, we can add a value of A that is missing. So how can you do that? So to do that, we use an if statement. Say if missing level and test score is greater or equals to 80, then we can say the missing level value is A. However, if we are missing level and we look at the test score, we see that it's less than 80 and that test score is greater than 70. So we can say this is a B student. Else, if we are missing level and test score is less than 70, then its level is C. So run that. So we can have a look into how this data set looks like. And again, I want to repeat this code. So we looked into what is missing and we said, okay, if we are missing a grade level of a student, we can look into the test score of a student and say, okay, we know that the student got 92. So we know that the level is A. So this is what we did in this case. Because what determines the grade level of a student is if the student's test score is greater or equals to 80%. So let's run this. And as we can observe, we no longer have missing values. So this is how missing function works in SAS. Following is we are going to look into how we can handle duplicate. In this video, we are going to see how can we use a sort procedure to handle duplicate in SAS. First, let's have a look into our data set. So in this data set, we can observe that this row is exact the same as this row. So row 2 and row 20 are exact the same. So there are also other rows that are the same, but that is what we can see for now. So let us see how can we use a sort procedure. So this is a sort procedure. Right. So the data that we want to use is this data set. So we want to output a clean data set without having duplicated rows. And we have nodupracs. So nodupracs, as we can observe, it checks for and eliminate duplicate observation. So we use nodupracs, and we want to take a duplicate and say a duplicate scores. Let's just say scores, and right. So this is to just say by all the rows. So make sure that the rows that are duplicated are adjacent to each other, so that when we look into our output, so let's print our output, which is 2PS scores. So this is for duplicate, and we now want to see how does clean should have had that clean plus scores and run. Hey, and if you run this, we observe that these were duplicated values. So SAS will only keep one observation of the two. So the entire row was duplicated. So with using nodupracs in sort procedure, we can be able to remove the duplicated rows in SAS. Hi, and welcome to this section part of the course. In this section, we are going to look into various statistical tests that allows us to evaluate model assumptions. So, as we all know that certain machine learning algorithms have drawbacks, and one of those drawbacks is multicollinearity. If two or more independent variables have a linear relationship between them, then we have a problem of multicollinearity. But why do we even care about multicollinearity? So let's say our data set has a problem of multicollinearity. So that means that the variances and standard errors of the regression coefficient estimate will increase. So this means we will have lower t statistics. So by ordinary least square, we cannot generate estimates of regression coefficients. So if we cannot do that, we might have an algorithm that will lead us to having wrong conclusions, and we don't want that. So how can we detect multicollinearity using SAS? So we have various ways we can do that. One of those ways is by looking into the VIF values and condition index. So a VIF of 10 or more, it actually indicates multicollinearity problem. And we can also look into condition index numbers. So a condition number that is between 10 and 30 will indicate the presence of multicollinearity. And when this value is greater than 30, then that multicollinearity is regarded as strong. So let us look into how we can use PROC to find the values of VIF and condition index in SAS. Welcome to this video. So in this video, we are going to be validating statistical assumptions. One of the things that I think all of us know is the fact that before we can simply just go and apply any machine learning algorithm like your regression or your random forest, we first have to clean our data. And one of the things or the drawbacks in so many machine learning algorithms like your regression or logistic regression is the fact that the variables, the independent variables, are sometimes correlated. So we have a problem of multicollinearity. So SAS provides us with some statements that we can use in order to deal with multicollinearity or detect it in our dataset. So in this video, we are going to detect multicollinearity. To do that, we have first defined this dataset. So this is the dataset, just a small dataset containing the need for hospital labor in 17 hospitals. So we have 5 predictor variables, which is the average daily patient load, monthly X-ray exposure, or monthly occupied bed days in the hospitals, and the eligible number of patients in the area, or we can say in this particular area, or in this case we're talking about the state. And lastly, it is the average length of patient stay in the hospital. So the dependent variable in this case is monthly labor hours. So let's run our data to see how it looks like in SAS. So this is how our dataset looks like. So we can observe that we don't have a problem of duplicate or missing values. So let's just see how can we detect multicollinearity. One way we can detect multicollinearity is by making use of variant inflation factor, or VIF. So first we will use VIF to detect multicollinearity. So VIS can be used to measure multicollinearity. So we will look at its value. If it's a value of 10 or more, then we have a problem of multicollinearity in the data. So the first thing that we do in SAS is we turn on our graphics so that we can be able to visualize. And the procedure that we use in order to find the VIF is PROC reg. So we have an option to state our data, which is hospital. Now, the model statements, that is where we will list the dependent variable and independent variables. So our model looks like this, is that we have labor hours as our dependent variable, and we have these additional independent variables. So I'm just going to quickly type all of them. Okay, so now we can observe that SAS provides us with options as to what do we additionally want to see in the output. In our case, we want the VIF. Okay, so first, this video will only show how can we interpret the VIF in SAS. And let's click run. So let us interpret our results. So the table that we want is a table of parameter estimate. that is where we can observe the value of VIF. So what can you see from the output? So from the output, we can observe that we have these three variables having a VIF of more than 10. So from VIF, we can say there is evidence of multicollinearity. Another way we can observe multicollinearity is if we make use of collinearity diagnostics. So collinearity diagnostics will help us to have a table that will show condition index. So from the condition index, we can also provide more evidence of multicollinearity. So this is and condition index. So we have an option of adding the table that will show us a condition index by adding colin, and let's run it. So the table that we want is collinearity diagnostics table. So how can we detect multicollinearity using condition index? When it comes to detecting multicollinearity using condition index, we look for the condition number that is between 10 and 30. So the condition number that is between 10 and 30 indicates the presence of multicollinearity. But when it is greater than 30, that is where we can regard the multicollinearity in our data to be strong. So the data set that we are working with has these two values when it comes to condition index, which provides further evidence of multicollinearity in this data set. So this is how we can use a condition index, which is from collinearity diagnostics table. Some machine learning algorithms, such as principal component analysis and some linear models, they assume linearity between the dependent variable and the independent variables. So we want to validate this assumption in SAS. The two ways that are going to be demonstrated in this course is Pearson correlation test and residual diagnostics. So what do we want when we're using Pearson correlation test? So we are going to be looking into a p-value. If the p-value is less than 0.05, that will indicate that the correlation is statistically significant between dependent variable and independent variables. So that is one way we can actually say we have statistically significant linearity. And the other way is by looking into residual diagnostics. When we're looking into the plots of residuals, we want randomness in the residuals. So that will indicate statistically significant linearity between the dependent variable and independent variables. Logistic regression and linear regression also has an addition assumption such as linearity. So we want to prove that linearity exists between the dependent variable and independent variable. To validate that assumption, we can use correlation test. To do correlation test in SAS, we will use this procedure. So this procedure, we call it first to be able to visualize. So this is your PROC core. So PROC core will allow us to do correlation test in order to validate if there is linearity between our independent variable and dependent variable and independent variable. So data is hospital, right? So the independent variables being all of these. These are all the independent variables, and we want to test with our dependent variable. Let's run that. Okay. Now, from the result, we will use Pearson correlation coefficient test statistics. So, in this case, we can observe that the p-values for all these correlations coefficients, all of these p-values are less than 0.05. So at a 5% level of significance, we can say that labor hours is linearly correlated to patient load, X-ray, bed days, area. However, this is not statistically significant for this variable. Well, this might be due to the fact that there might be influential observations in our data set. Following, we can also visualize this correlation by adding an option which is plot. Plot will allow us to make visualizations of this correlation. Let's run it. So the scatter plot matrix. So this scatter plot matrix allow us to visualize this correlation. So we can observe here that there is somehow a linear shape. We can observe that there is somehow a linear shape in this result, or in the scatter plot matrix result. So that is how we can use correlation to validate an assumption of linearity between the dependent and independent variables. Another way that we can use to validate an assumption of linearity between dependent and independent variable is by using residual diagnostics. So let's view the graphics and say PROC. I'm just going to copy all of this. Right. So we have an additional option to plot the residuals. So we say residual plot. However, we want to visualize this, then let's run this. And this is the plot that we are interested in. So from the plot of residuals, the independent variables, they indicate randomness. There is no pattern. So which means that there is linearity between each of the independent variables with our dependent variable. If we can observe here, there is actually no pattern that is formed in the residuals. So there is randomness in the data set, which is what we want. As we all know, normal distribution is one of the most famous distributions in statistics. So most of the machine learning algorithms, especially linear models, They are based on the assumption of normality. In this section, we are going to see how can we test for normality in our data set. So the most famous test for normality is Kolmogorov and Shapiro-Wilkes test. But for data sets of 2000s or larger, Kolmogorov is most suitable. However, for data sets that are not that big, Shapiro-Wilkes test for normality is the most suitable. Let us head over to SAS to see how can we use SAS procedures to test for normality. Normality assumption. How can we validate normal distribution in our data set? How can we make sure that our data set follows a normal distribution? Well, normal distribution is a widely known distribution in statistics, and most of the algorithms, they assume that the data follows normal distribution. So how can we make sure that our data follows normal distribution? Well, the most famous test that we can use is a Shapiro-Wilkes test or a Kolmogorov test. But let us see how can we do that in SAS. SAS provides a procedure univariate that can enable us to do normality test. So PROC univariate and our data. Right. Because we want to perform normality test, we have to specify this option test normal. So as we can see here, it requests test for normality. So that is what we want. We want a test for normality. So I'm just going to copy the independent variables, and we are ready to run and interpret. So there is a lot of tables when we're using PROC univariate. However, this is our interest, test for normality table. So let us interpret. We know, according to SAS manual, that if the sample size is over 2000, the Kolmogorov test, this test should be the one that is used. However, in our case, we simply just took a small data set. So this Shapiro test is the best to use. So the Shapiro test, it tests the hypothesis. So the null hypothesis is that the data is normally distributed. So let's see what can we say from the given result. Looking into the result, we can observe that the p-value, we will use the p-value. So the p-value at a 5% level of significance compared to 0.05. This p-value is less than 0.05. And we will reject the null hypothesis of normality. And what can we conclude using Shapiro-Wilkes test? We can conclude that there is sufficient evidence to suggest that our data is not normally distributed. That is what Shapiro-Wilkes test tells us. We look at the p-value, we can see that this p-value is less than 0.05. So we reject the null hypothesis of normality. So we can also see that there might be some redundancy in our data set that might be caused by unusual observations, which is why when we continue, we are going to see how can we detect outliers and influential observations in SAS. In this section, we are going to see how can we detect outliers and influential observations in the dataset. We all know machine learning such as gradient boosting regression and decision trees. So these machine learning algorithms, they are sensitive to outliers. So it is the best way to detect outliers using SAS. So in SAS, we can detect outliers by making use of Cook's distance, the outlier and leverage diagnostics, and also defeats and DF betas. So the best way in which we can detect outliers using SAS is if we visualize, we make visualizations. We can also use box plots and tests such as Rosner's test. However, in this course, we are going to be looking into these three ways in which we can use to detect outliers in SAS. Let's head over to SAS Studio. Coming to the last part, we observed that our data does not follow a normal distribution. So there might be influential observations. So in order to detect influential observations in SAS, we can use DF beta statistics and some plots like Cook's distance. We can visualize Cook's distance in order to see those observations that are unusual. So let's do that. First, let's turn our graphics on to visualize. SAS also uses reg procedure for detecting outliers. So this is our data set. We will list all the options that we require. First, we have our model and run that. So first, we want to be able to visualize Cook's distance, and to do that we have option plots. This option will allow us to visualize Cook's distance, DF betas and defeats in order to detect influential observations. So let's say we also want to label so that we can see which observations are unusual. So let us list the plots that we want. We want Cook's distance, defeat, and DF betas. Let's run that. Now these are the results. From the result, our interest is in the Cook's distance. Now what we can observe from the plot of a Cook's distance, it's Cook's distance just showing us that there are several observations that are unusual. If we can observe here, we can see that observation 15, 16, and 17, and 10, those are unusual. Those are outliers. In fact, they are highly, in observation 16, it's highly influential observation. And looking into defeat, when we are using defeat and DF betas, we have a cutoff of 2. So we can also observe that these observations 16, 17, 10, and 15, also when using defeat and DF betas plots, they are shown to be valid outliers or influential observations.